Hello guys, welcome to the DMS online school. In today's chemistry lesson, I will be teaching you extraction of copper metal. Alright, so if you are new to this channel, you are most welcome. And on this channel, I teach mathematics, biology, science, and also revise past examination papers. So if you haven't yet considered subscribing, please click on the red subscribe button below and you will not be charged anything. It's free of charge. Alright, so guys, let's go straight into the video. Alright, so before we go any further, we are first going to look at functions of raw materials in the extraction of iron metal. So I did the extraction of iron metal in my previous lesson, and I never talked about the functions of those raw materials used in the extraction of iron metal. So I thought it very important that I should talk about them in this lesson before I look at the extraction of copper metal, which is the very important lesson, because trust me, you go on the internet, you search and look at the extraction of copper metal, you are not going to understand the way I'm going to explain it in this video. Also, you can watch so many videos on YouTube about extraction of copper metal. Trust me, you are not going to find any video that is going to explain clearly the extraction of copper metal like I'm going to do it in this video. So please don't click off the video, continue watching up to the end and give it a like, because you are really going to enjoy it. Alright, so let's look at the function of the raw materials used in the extraction of iron metal. Number one, we are talking about hematite. What is the function of hematite? Hematite provides iron metal itself. All right, so the next raw material is limestone. All right, so limestone contains calcium carbonate, which produces calcium oxide. All right, so what does calcium oxide do? You should know that calcium oxide is used to remove the impurity silicon dioxide from iron metal. That's what it does. All right, then the other raw material is coke. All right, so coke contains carbon, which reacts to form carbon monoxide, and this carbon monoxide reduces iron 3 oxide to form to iron metal by the process called the reduction method. All right, so these things you must understand them. Then we have also oxygen. All right, so oxygen, what is its function? So we are saying oxygen oxidizes carbon, all right, into carbon dioxide, which further reacts with carbon to form carbon monoxide. All right, so that's what oxygen does. It just oxidizes carbon into carbon dioxide, which further reacts with the carbon to form carbon monoxide. All right, now let's look at the extraction of copper. Now we have started looking at the extraction of copper. Guys, get excited. This is a lesson that you are going to enjoy. All right, so let's begin with this. So the chief ore from which copper is mainly extracted is charcoal pyrite or chalcopyrite. All right, so this is how it looks. So look, it's a very beautiful ore, like also this one here, also this one here. So these are the beautiful ores from which copper is extracted. All right, so what you should know is that the chemical name for chalcopyrite is copper iron sulfide. All right, so this chalcopyrite, its chemical name is copper iron sulfide. All right, and the chemical formula of chalcopyrite is Cu, which is copper, then Fe, which is iron, and Sc2, which is sulfur. All right, so copper is extracted from chalcopyrite by roasting and reduction method and purified by electrolysis. So this is what you should do. Now let's look at the stages in the extraction of copper. So we are now going to look at the stages in the extraction of copper. So we have the first stage here, which we call concentration of the ore by frothy flotation process. So the ore needs to be concentrated by frothy flotation. All right, so by concentration, it means that you just remove any soil which is there and any unwanted material which is not part of the ore. You get rid of it, and that process is called um, frothy flotation process. So what happens here is that copper is crushed into fine powder and mixed with water containing little amount of pine oil. Then a blast of air is blown through the mixture, and the frothy containing pure copper ore floats on the surface of the mixture. Then this process produces what we are saying more concentrated copper ore called the concentrate. All right, so let's push it up here so that you understand. So this is what happens here. So this is what happens during the concentration of the ore by frothy flotation process. So this is actually the mixture I'm talking about, the mixture of crushed copper ore with the water mixed with the pine oil. Then this is now showing air, compressed air goes through it, then it forms a frothy. A frothy is just a foam, like when you are washing that material, bubbles which form are called foam or frothy. So when a mixture of copper here is crushed and mixed with the pine oil and the water, then air is blown here, then this frothy forms here. All right, so this frothy, actually now when you look at it, frothy bubbles carrying sulfide or particles. All right, so this is the one, sulfide or particles. All right, so water containing pine oil. All right, these particles now floating, these particles now will contain the actual ore, leaving any dirty at the bottom here. All right, so that's why we are saying copper is crushed into a fine powder and mixed with the water containing little amount of pine oil. Then a blast of air is blown through the mixture, and a frothy containing pure copper ore floats on the surface of the mixture. So this one floating on the surface of the mixture. So this process produces more concentrated copper or called concentrate. So this now is removed as shown in the next diagram here. So if after this forms, which is concentrate, copper concentrate, it is formed, all right, or I mean it is collected somewhere here, and then it is ready for the next process. So this one is called copper concentrate, and it contains more copper than the initial one. All right, so the next stage is roasting of concentrated ore in air to obtain copper sulfide. So what you should know here is that now concentrated copper ore is roasted in hot air to burn away sulfur. All right, so there's a lot of sulfur in chalcopyrite, so the concentrated ore is roasted in hot air to burn away sulfur. That's what happens in this stage. So when it is roasted in air, this is the equation which is supposed to be known. So here, this is chalcopyrite, which is copper iron sulfide. Then after being roasted in oxygen, which is air, then it gives you copper sulfide, then also iron oxide, then plus sulfur dioxide gas. So these are the products of this process. So it removes the sulfur away. So sulfur goes away, most of the sulfur goes away. All right, so now this equation is not balanced. Here copper is 2, here we have 1, we put a 2 here. Again, if you check properly here, you'll find that here sulfur is plus this one is actually 4. Here sulfur is just this sulfur here plus this sulfur here, so it is just 2. So we put a 3 here, so that this 3 sulfur and this 1 sulfur here, it becomes 4, just as it is 2 times this 2 here, 4 sulfur. Then the next thing here, you need to balance iron. You realize that here we have 2, meaning iron is 2, but here iron is 1, so you put a 2 there. Then the next thing you realize is oxygen. Oxygen here is actually 2, but here it is 2 here. Then 3 plus 2, 6, plus this 2 of oxygen here, 8. So for you to make it 8, you put a 4 here. 4 times 2, 8. All right, so this is what happens at this stage. So roasting of concentrated ore in air to obtain copper sulfide. All right, so in this process, actually what happens is you just roast the concentrated copper ore in hot air to burn away sulfur. All right, then this one which is formed here, which is copper sulfide, now goes for the next stage. So the next stage is smelting to remove iron and obtain copper. So there's a smelting to remove iron and obtain copper. So this iron is still together with this. This is the only thing which escapes because this is the gas. Then now what happens during smelting is this. So the roasted ore is mixed with this silica, all right, which is actually sand, and roasted again. So this roasted corrected here is mixed with the silica and roasted again under the smelting process. All right, so silica reacts with the iron oxide to form a slag as iron silicate. So this iron oxide here now react with the silica to form a slag called the iron silicate, this one here. In this way, iron is removed from the ore. So this is how iron gets removed from the ore. So the equation for the reaction is as shown. So iron reacts with the silica, then it forms iron silicate. All right, so this leaves more concentrated mixture of copper sulfide with some iron sulfide called uh, copper mate. So after this process has taken place, what is formed now is a more concentrated copper sulfide or material, which contains some iron sulfide. So this mixture of copper sulfide and iron sulfide is called copper mate. All right, so this is what is produced at this stage. So what have you seen on this stage? We have seen that on this stage, the roasted ore is mixed with the silica and roasted again. Then silica reacts with iron ore to form a slag as iron silicate. In this way, iron is removed from the ore. This is the equation. Then this leaves more concentrated mixture of copper sulfide with some iron sulfide called copper mate. All right, so this now copper mate goes for the next stage. So this next stage here is reduction of copper mate to obtain copper metal. So here what you should know is that the copper mate is introduced into a Bessemer converter where air is blown through the molten mate. So some of the copper sulfide is converted into copper 2 oxide. So since copper mate, remember copper mate, we said it is a mixture of copper sulfide and iron sulfide. So that copper sulfide during this process is converted into copper 2 oxide. All right, some of it is converted into copper 2 sulfide. Then we are saying copper sulfide and copper 2 oxide reduces each other into copper metal and sulfur dioxide. So that copper sulfide that converts into copper 2 oxide, we are saying not all of it does the conversion, because we are saying some of the copper sulfide is converted into copper oxide 2 oxide. Then copper sulfide that has not converted into this, and copper sulfide, this one here, reduces each other into copper metal and sulfur dioxide. So copper sulfide and copper 2 oxide reduces each other into copper metal and sulfur dioxide. So this is the equation which produces or this is the main reaction which produces copper, and this is the equation. So we have copper sulfide, this one here reacts with copper 2 oxide, then this reduces each other to form copper plus sulfur dioxide. So again, you balance this equation. How do you balance this equation? You check. So here you'll find that actually we have you are supposed to actually put just a 2 here. That's how you balance it. Then you put also a 6 here, so it is balanced. So then the copper obtained is called blister copper, because as it solidifies, sulfur dioxide hidden in it escapes out, producing blisters on its surface. So this copper which is obtained here, it is called blister copper. All right, so let me show you why it is called blister copper. So this is why it is called blister copper, because these parts here, let me show you even this one. So these ones are called blisters. So that's how it appears as blister copper. So the copper, which is this one here, obtained is called blister copper because as it solidifies, sulfur dioxide hidden in it escapes, producing blisters on its surface. So I hope you know what blisters are. All right. So let this one go. So we are saying blister copper is about 98 to 99.5% pure. So it is not yet 100% pure. So it contains the impurities, mainly iron, but little amount of arsenic, zinc, lead, silver, and gold may also be present. So it also contains some other impurities. All right. So that's why it is at 99 or 98 to 99.5% pure, because it has some impurities of iron there, arsenic, zinc, lead, silver, and gold. All right. So these impurities adversely affect the electrical conductivity of copper. So we are saying these impurities adversely affect the electrical conductivity as well as mechanical properties of copper. So therefore, they must be removed by refining. So this copper now, which has been produced here, is not ready for use, because mainly copper is used as a conductor. So because of these impurities, they are going to disturb the conductivity of copper. So they have to be removed so that we come up with pure copper, which now is able to conduct very, very well. So now we are saying most of the sulfur in the chalcopyrite turns into sulfur dioxide. This is used to make sulfuric acid by the contact process. So as you have seen in the process of extraction of copper metal, we have seen that the sulfur dioxide is produced even in the first reaction and even in the last reaction. So this sulfur dioxide is a pollutant. If it goes into the atmosphere without getting collected, then it brings about acid rain, but it is collected in mines to produce sulfuric acid by the process called the contact process. Now let's look at now purification of blister copper by electrolysis. So this is the electrolytic cell. This is the process in which the purification of copper is done. All right, so we are saying that blocks of blister copper as anodes and thin sheets of pure copper as cathodes are dipped into an electrolyte of copper to sulfate. So this is what happens. So you get blister copper which act as an anode. So here you have this one as an anode, then which is impure copper. Blister copper is impure copper. Then this is connected to the cathode. The cathode, I mean the anode, is the positive terminal of the battery. All right, and then we have already pure copper, which is also connected to the negative terminal of the battery, and that negative terminal of the battery is called the cathode. So this is what happens. So you have this cell here called the electrolytic cell. In it here contains copper 2 sulfate solution. This is copper 2 sulfate solution formula. So then you get the impure copper, which is blister copper. You connect it to the positive terminal of the cell, and since it is connected to the positive terminal of the cell, then it can be called impure copper anode. Then you get already made pure copper, connect it to the negative terminal of the battery, and that pure copper can be called pure copper cathode. All right, so then after this arrangement has been done, then we are saying an optimum voltage of 1.3 volt is passed through the electrolyte. So current now passes here in this circuit, and it decomposes into copper 2 ion, and which are these Cu2 plus, and sulfide ion, which is SO2 minus 4. So when current now passes into this copper 2 sulfate here decomposes into ions, this and that as shown. So these, they will decompose into ion. They will exist as the ion like this. All right, as they exist as ion now, what you should know is that the next thing is that copper 2 ions that are formed, these ones here, we have copper ions, these ones here, are attracted to the cathode. At the same time, blister copper at the anode loses 2 electrons. So since these copper ions are positively charged, and this cathode here is negatively charged, so these will get attracted to the cathode. These are positive copper ions. They will be attracted to the cathode. At the same time they're getting attracted, this copper cathode anode here is going to lose 2 electrons. All right, so this is what you are going to see here. So what you are going to see, there will be loss of 2 electrons here. All right, so first of all, let me show now. So we have said copper 2 ions are attracted to the cathode. At the same time, blister copper at the anode loses 2 electrons. All right, so these ones now, they'll be attracted to the cathode. So let me show how they are getting attracted. All of them, they will be attracted. So here they have been attracted to the cathode because they are positively charged and the cathode is negatively charged, and you know negative positive do what? Attract. That's why they get attracted to the cathode here. All right, so what we are saying here is that when this happens, then this copper anode here, which is impure copper, will lose 2 electrons. So there will be electrons that are going to be lost here. So there will be electrons here, like these 2 electrons formed here. then these electrons are going to be lost. All right. So what we are saying here is that the lost electrons are transferred through the external circuit to the cathode to join copper ions to form copper atoms. So these electrons here, they'll transfer through the external to come and join these ions here. So when they join these ions, they'll form copper atoms. So this is what is going to happen. So this one is going to move. Watch as it move. Yeah, so it moves and it comes here. So when it comes here, this one gains electrons, gains 2 electrons, these 2 copper ions. Uh, uh, this copper ion charged with 2 will gain this electron and become an atom and then get stuck to this like that. So it has gotten stuck to that. Then what we are saying here is these copper atoms that have lost 2 electrons form copper ions. So this copper atom, any copper atom here that loses those electrons that went this way, that copper atom forms copper ions, which goes into the solution to replace the copper ions from the surface being attracted at the cathode. So those which were attracted, remember the one which was here has already joined with the electron and it has become an atom which has joined this pure copper cathode. So because it has been removed, it has to be replaced with another one. So that one which lost that electron, that copper atom here, to form a copper ion and it will go into the solution to replace that one which has been uh, attracted. So this process now will go on and on. So let me just reverse. So notice, so what happens, you notice here, so as those um, copper ions which were here receive those electrons and join here, this one becomes big, and this one, because it will lose this copper ion here into the solution, it starts getting smaller. So this one, notice what is happening to its size and this one. So this one, the size has become bigger and this one has become smaller. So we are saying as copper atoms get deposited at the cathode, so there will be copper atoms that will be deposited at the cathode. The cathode gets bigger with pure copper, so it will start getting bigger with pure copper because those atoms to be receiving are pure atom of copper. All right. Then as copper 2 ions goes into the solution, those copper 2 ions goes into the solution, the anode gradually disappears. So this one will start disappearing. Any metal in the impure anode, any metal which will be here, like we talked about, there's they said there's iron which is in impure copper blister. We talked about there's gold, we talked about silver, we talked about arsenic. So we are saying any metal in the impure anode here, which is below copper in the reactivity series, does not go into solution as ions. So those will not go into the solution as ions. All right. So this process goes on until everything has moved and it has gone into this one. So this will continue. So again, there will be 2 electrons that will be formed. These electrons will travel, then join with this ion again will be formed. This one will join, will move, this one will join, form an atom will join on this one, and this one will become big again. This one will lose some electrons again, will move again continuously. This one will form ions. Since it has lost that electron, it will come here. This one is going to join, so it will join, so this one will continue becoming big again. This one again will move again, just like that. All right, so come here and an ion will be formed. It will travel, this one will join with that, form an atom. This one will become big, this one smaller. So it is, this one is becoming smaller, this one big again, it loses. All right, this one passes again, this one forms an ion, this one joins, this one becomes bigger, and this one smaller. All right, so you have seen it has become smaller and smaller. So it will still, until there's no copper ion atom remaining here, all of them, they'll be transported like that. So now this part now is going to be pure. This one will now be pure metal. So now what will remain here is there will be something that will remain at the bottom here, which we call anode sludge or gold, which contains gold, silver, and other things, etc. here. All right, so this is what happens in the purification of copper. So this is how copper gets purified, and this one becomes pure copper. Then here you remain with nothing. All the atoms get transported in forms of ion to this side where they gain electrons, and then they become atoms and get deposited and gets this cathode become bigger and bigger. Now, especially those that are doing pure, it's very important that you understand the reactions at the anode and at the cathode. So we are going to start with the reaction at the anode here. So what we have seen at the anode is that copper atom here were losing. So they were losing. So we say copper atom were losing 2 electrons. So this is how you write the equation, meaning copper, here we have copper, so atom are losing 2 electrons to form copper ion, those which we are traveling here. Then now you also know what is happening at the cathode. So reaction at the cathode. So at the cathode, we have seen that the copper ions which were here, they were accepting electrons. Then when they accept electrons, 2 electrons, then they were forming copper uh, copper atoms, which were making this cathode to be bigger and bigger. All right, so guys, if you have enjoyed this video, please give it a like and let me know also in the comment section. All right, so again, you might be missing an opportunity, guys. So for those of you that want to perform very well in science, please, I'm already conducting online tuitions in my WhatsApp. So probably if you want to be able to see other lessons coming frequently on my channel, it is because I'm busy in that group. So for you to also continue enjoying those, you must also do what? Join. So it is just 60 kwacha physics, chemistry, 60 kwacha mathematics, 60 kwacha biology, 60 kwacha. So these are ongoing tuitions. If you are GCE, you can join. If you are doing next year, you can join. So I'll never stop offering online tuitions. All right, so this is where it comes to an end. But before you go, you have to look at in reality now, how does this happen in reality? So in reality, this is just a demonstration. So in reality, this is what happens in a real mine. So in a real mine, these are what we are calling the cathode, which are dipped into the electrolytes. These are electrolytes here. So in these ones, there are impure, like those which are down there. Those which are down there must be the impure anode. These ones must be the pure cathode, which must be dipped there. When they become big, they are removed. So these electrolyte cells, when things are dipped like that, they have been dipped. The process of electrolysis is happening. This is what it will happen in a mine. So when they are removed now, these they have already accumulated, now they will look like this. Then these now they are removed and they are packed in stacks like this, ready for selling and then ready for turning into wires and other things that use copper wire. All right, so guys, we have come to the end of this uh, chemistry lesson on the extraction of um, copper metal. So guys, as I told you, this has been a wonderful lesson. Please give it a like if you haven't done so, and also subscribe by clicking on the red subscribe button if you haven't done so. And please let me know in the comment section if you have learned something in this video. Guys, for now, bye and see you in the next lesson. Please, peace.